This is a linear pair. So if this is 115, this automatically becomes 65. I'm going to use my knowledge of similar triangles. Okay? So they want the length of, they want this length, BC. So let's compare the triangles. This angle is this angle. That angle, I'm gonna put it in a different color. This angle green is this angle right here. And of course, these are vertical angles. So, oh, now I know what's going on. Look, this angle is congruent to this angle, right? Now, these are vertical angles. And vertical angles are always congruent. So if two angles of one triangle are congruent to two angles of the other triangle, then the third angle has to be congruent. So all three angles are congruent. So my conclusion is that these triangles are similar. Now, because they are similar, now I can start working on setting up a proportion to find the length. So how am I going to do this? Easy. This 4, okay, this DC, this 4 corresponds to what? Well, this 4 is opposite to this angle, and this angle is this one, right? Yes? Okay, so what's opposite to this one? X, right? So far so good? In other words, let me see this side. Oh my God, I'm getting confused. This 4 DC corresponds, okay, 65. 65 is opposite to 6. 65 is opposite to, okay, you know what? I'm going to start like this. 65, 6 is opposite to 65, so I'm going to start with the 6. Okay, and now on the big triangle, what's opposite to 65? 15. Okay, beautiful. And now, I'm going to go to 4, okay, on the small triangle, okay, which is opposite to this. So therefore, this is opposite to this one. So this is X. I don't know what X is, so that's what I'm going to find out. Man, this is giving me a headache. So 15 times 4 is 60, and 6 times X is 6X. Divide by 6, and X is 10. And that's it. Alright, so I'll see you on the next session. Damn, this was hard. Alrighty, so let's do the next problem. In diagram below, lines L, M, and N, okay, L, M, and N, and P intersect line R. Okay? So now, what is it that they want? Well, they're asking, which statement is true? Is line L parallel to line N? I'm sorry, is line L parallel to line N? Well, let's see, L to N. Well, it's easy to look at it, right? They're not parallel, but anyway, we have to prove beyond the doubt, benefit of the doubt, that they're not. So, this angle, if they were, okay, let's do a counterexample. If they were parallel, then this angle right here, all obtuse angles should be congruent. So this should be 112. But guess what? These two are vertical angles, and vertical angles are supposed to be congruent. So therefore, this is 122, this should be 122, so this is not. So choice number 1 is not. Alright, choice number 2. L is parallel to P. L is parallel to P. The way I look at it is like this. They look parallel, right? But anyway, once again, I have to prove beyond the benefit of the doubt that they're not. So, let's see. Okay, so these two angles add up to 180. So figure out how much would this angle be, and then tell me. Right. This angle is 122. Why? Because they add up to 180, right? No, wait. 122. No, 112, sorry. They add up to 180. And now look at these angles. If this is 112, this is also 68, right? So this angle and this angle are called corresponding angles because you have parallel lines cut by a transversal. So these corresponding angles are supposed to be congruent. If they are congruent, then the lines are parallel. Therefore, your answer is choice number 2. Okay? Oh my God. Let's do this problem. This is gonna be a crazy problem. Let's see. Right, the next problem, it says, prove that the sum of the exterior angles of a triangle is 360. So these exterior angles supposed to add up to 360, but how am I gonna prove that? Well, it's gonna be a difficult task, but let's do it. Now I'm gonna minimize it. You already know what the task is. I'm minimizing it so I can have space to write on. Okay, look at this triangle. So this angle, can I say that this angle and this angle add up to 180 because they are a linear pair? Can I say that? Sure. All right. And I also can say that this angle plus this angle, it's 180 because they're a linear pair. And I can say that this angle and this angle are a linear pair, so therefore they're 180, right? Okay then. So now that I know where I'm going with this, then I can start writing my proof. So let's see. I wrote that the sum of the angles of a triangle add up to 180. What does that mean? That they all add up to 180. Okay, so then that's where I'm gonna start. So I'm gonna start saying the following. Measure, okay, now I'm gonna use the whole page. Measure, that is supposed to be what's next in here. I just decided to write it over here. Measure of angle ABC plus measure of angle FBC. FBC, you know which one is FBC? FBC, this angle right here. So measure of ABC, right? ABC, this angle plus this angle is 180, correct? All right. So equals 180 degrees. Then I'm gonna say that the measure of this angle and this angle is 180, and the measure of this angle and this angle is 180. We have to be very specific. That's why. All right. So comma. Uh-oh, I need something to drink. And this is too much. And okay, finally. So I said that all linear pairs are supplementary and that they all add up to 180. All right then, so what else do I need? Well, by addition, okay, so I'm gonna write this, another sentence. By addition, so by addition, the sum of these linear pairs, the sum of this, this, and this, okay, is 540, correct? Now, so all the angles are 540. Like the sum of this 180 plus this 180 plus this 180 is 540. So now what happens when we subtract the measures of the interior angles of the triangle? Okay, so we say Okay, oh my God. So let's see, this is what I wrote. So, all right, so we have the triangle here. So we know that the sum of all these angles is 540. Then when we subtract the 180 from the interior angles of the triangle, then the result is 360. So what happens if you have all the angles, right, and you subtract the interior, then you only end up with the exterior. And when you add up the exterior, you end up with 360 degrees, which is the sum of the exterior angles. That's it, right? All right, so that's it. That's how you prove that the sum of the exterior angles in a triangle is 360. And be careful, because when they ask you, prove that the sum of the interior angles of a triangle is 180. Well, this same proof can be used for that one, okay? Got it? Because you know that the exterior angles now add up to 360. Anyways, let's move on to our next example. Alright, so this problem says, segment CD is the perpendicular bisector of AB at E. Which pair of segments does not have to be congruent? Okay, so I'm not going to do the construction. I'm just going to model for you, okay? So I have, let me see. I have a segment called AB. So let's say I have segment AB, right? And then I have, so this is segment AB. I'm going to label it AB. Because it says that segment CD is the perpendicular bisector of AB. So segment CD, so I'm going to do segment CD, right? Now, why did I cross all the way down? Well, because it says segment CD. All right? CD is the perpendicular bisector at E. So this point right here, okay, is E. This point right here is E. Which pair of segments does not have to be congruent? Well, we know that, okay, AD, okay, wow, now I have to connect them. Okay, AD. So let me connect them. Okay, now I connected them, so I don't know what's going on. All right, so which pair of segment does not have to be congruent? AD and BD. AD and BD. Actually, these two pair of segments are congruent. Okay? They have to be congruent. Because segment AE is congruent to segment EB. These two segments are congruent. Right? Now, anywhere you go on the perpendicular bisector, right, you're going to have the same distance from this point to this point, than from this point to this point. Okay, they are equidistant. They form an isosceles triangle, so they have to be congruent. Okay, what else? And also, like, for example, look at this. This is a right triangle, okay, and this leg right here is congruent to this leg right here, right? Plus this segment right here, this is a right angle, right? Okay. This segment right here is also congruent to itself by the reflexive property. So we already have two sides congruent, right? And in a right triangle, if two legs of one right triangle are congruent to two legs of the other right triangle, then the hypotenuse have to be the same length. All right? So then this is not the answer, because we're looking for which one does not. AC to BC. AC and BC, again, the same explanation as this one. So they are congruent. They have to be congruent. So number 2 is not the answer. Number 3, AE and BE. AE and BE. Come on, this is the perpendicular bisector. So it bisects this segment. So this is congruent to this one, so that's true. Therefore, correct choice is number 4. But let's see why. DE. DE and CE. And CE. They don't have to be congruent. All right? Why? Because, look, actually, I don't even know if they have the same length. Look, this is all the way to here. So the other one should also be all the way to there. Look, it's not, it's a little bit. But I could have just gone like this. I could have extend this over here all the way. And I could have, and when I connect them over here, okay, this would still be congruent to that one, but this length would not have to be congruent to this one. That's basically what it is. So choice number 4 is the right choice. Hopefully you understood this. Okay, here we go with this problem. So it says the aspect ratio, okay, of a rectangular flat screen TV is 16:9. That's the ratio of the width to height. So this 16 belongs to the width, this 9 belongs to the height. So far so good? Yes. Now it says the length of the diagonal of the screen is the television screen size. Yes, we all know that. When you're going to buy a TV at the store and they say that it's 55 inches, they don't mean that you're gonna go like 55 inches or 55 inches or 55 inches or 55 inches. No, it means that the diagonal here is 55 inches. So you want a visual? Fine, I give you a visual. Boom. Okay. Let me see, right there. And then you go like this. Just cut, right? So this is the rectangular TV. So what I'm saying is that the length of the TV, the size of the TV is measured by either this diagonal or this diagonal. That's when they say 55 inches. This is 55 inches. Got it? Okay, cool then. Now let's see what's going on. Determine and state to the nearest inch the screen size, okay, diagonal of this flat screen TV television. And it has a height of 20.6 inches. So the height is 20.6 inches. So we know the height, okay? Now notice, because you have to use your common sense and you have to use your critical thinking and analytical skills. Notice that this diagonal forms two right triangles because a TV is a rectangle, so these angles are 90-degree angles. So this right here, I'm going to focus on one of the triangles, okay? I'm gonna focus on one of the triangles. I'm gonna focus on this triangle right here. But first of all, I need to know something. It says that the ratio, okay? The ratio of the TV of the width to height is 16:9. So for every 16 inches, okay, of width that I have 9 inches of height. For every 16 inches of width that I have 9 inches of height. Okay? Now, the width, okay? The width of the rectangle is 20.6 inches. No, the height of the rectangle is 20.6 inches. So basically, I'm gonna create a proportion. For every 16 inches of width, I get 9 of height. So I need to know what is the width when I have a height of 20.6 inches. So that, and that is just part of it, because if I am going to find out what the measure of the diagonal is, I need to know what is the length of the hypotenuse of this right triangle. Okay then, so then we cross multiply, right? So 20.6 times 16, 9 times x, we divide by 9, and then x is going to be approximately 36.6 inches, right? Inches. If you don't believe me, then I'm gonna have to use the calculator, which I have no idea where I put the calculator. I'm nice. I'm always losing stuff. Nah, it doesn't matter. Anyway, oh, I found it. So let's see. So I cross multiply this, right? So when I cross multiply, I get, I'm gonna do it over here so you can see it. Okay, 20.6 times 16 is 329.6 divided by 9, 36.62. See? Okay then. So now that it's settled, we know that this width right here is 36.6. Now I have two sides of a right triangle. Now, and I want to find the third side. You know you're not going to use SOHCAHTOA. You know you're going to use the Pythagorean theorem. So what is it? Well, c squared equals to a squared plus b squared. See, even if I'm blocking it, I'm still dictating to you. All right, So c squared, this is the hypotenuse, opposite to the right angle. I don't know what it is, so I'm gonna call it, just call it c, okay, or x, it doesn't matter. So c squared equals to, now these are the legs. This could be a or b, or a or b, it really doesn't matter. So 36.6 square plus 20.6 square. Okay, now I add them up and I get c squared equals to, and what would that be? I don't know. Let's figure it out. So let's see now. 36.6 square plus 20.6 square is, wow, that's a lot. Oh, no, wait. Plus, okay. That is 1763. So c squared equals to 1763.92 inches. Now I need to find out what c is, the length of the hypotenuse, not c squared. C squared is area. So then I take the square root of c squared, okay, like that, and what you do to one side, you gotta do to the other. And now I wanna find out what the square root of 1763 is. Well, that is 41.999, whatever, right? Okay. But then he says, I need to determine and state to the nearest inch. Oh, to the nearest inch. So 41.9999 translates into, actually, like that, okay, means an estimate of 42 inches. And to be more specific, you have to write, okay, the length of the diagonal, okay, or the size of the TV is 42 inches. As simple as that. All right, let's move on to the next problem. Okay, here we go. So, let's see now. In isosceles triangle M and P, line segment and O bisects vertex M and P. So this line bisects this vertex. That means that if it bisects it, it creates the angle bisector. You understand what I'm saying? Okay then. Now MP is 16. MP is 16. Find the length of MO and explain your answer. Well, first of all, this is an isosceles triangle. So this right here is congruent to this right here. And angles opposite to congruent sides are also congruent. Okay? And since this and this angle is also congruent to this one, because this is the angle bisector, because he says it, that NO bisects the vertex. So now I have proven that these two triangles are congruent by angle, side, angle. Not only that, this side is congruent to itself. Okay? So they never said anything about these two sides, but look, if these two triangles are congruent by angle, side, angle, or by let me see, or by side, angle, side, or by side, angle, side, side, angle, side, then every other part of the one triangle is congruent to every other part of the every corresponding part of the other. You understand what I'm saying? Okay then. So now let's write the written explanation. So where do I start? I'm gonna start right here. Okay, so I'm gonna say the following: triangle MNO, okay, is congruent. Is, how do I write congruent? It's like that. It's congruent to triangle PNO. PNO. So this triangle is congruent to this triangle by, it's gonna be my choice. I'm gonna say side, angle, side. Okay, side, angle, side, side, angle, side. Okay, and now I'm gonna write, since triangle MNO, okay, since triangle MNO is congruent, right, to triangle PNO, okay, you pause it if you need to copy. Since these two triangles are congruent, then, okay, segment MO, that is this segment, right, is congruent to segment PO. Okay? By what? By the postulate that says that corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Civic tag, right? So therefore, NO, segment NO, must, oh my god, okay. So segment MO must, and I'm just gonna continue writing here, must divide MP in half. Don't think that just because you see it here and it looks like they're congruent that you're gonna say they're congruent. No, you have to prove that they're congruent by analyzing the triangles. Okay, usually in geometry it's all about triangles and circles, so this one is about triangles. So anyway, so it divides MP in half. Okay, so what? Well, in half. Therefore, and look at what the question is. Find the length of MO. Find the length of MO. Therefore, MO equals half of 16, which is 8. Make sense? So that's it. Okay, put it right here so you could see it. Although you just pause it and follow along. All right, let's move on to the next question. I'm telling you, you are going to pass that Common Core Geometry Regents if you just follow directions. If you have any questions, you could just make a comment or whatever. Okie dokie. So what am I supposed to do here? It says, in the diagram below, okay, the measure of angle BDC, this angle right here, okay, is 100 degrees. Okay, 100 degrees. Measure of angle A is 50. And measure of angle DBC, this angle, okay, is 30. Okay, cool then. So what's up? Which statement is true? Okay. So let's figure this out. Which statement is true? ABD is obtuse. ABD is obtuse. How am I gonna determine it? I mean, it don't look obtuse, but you know what? An obtuse triangle is a triangle that includes one angle that is obtuse. So let's figure this out. This is a linear pair because this angle plus this angle are supplementary. That means that they add up to 180. Okay. Now what else do I know? That the sum of the angles in a triangle is 180. So this must be 50. Okay, because 50, 50, 100 plus 80, 180. Okay? Or the exterior angle of any triangle, like this is an exterior angle, is equal to the sum of the two non-adjacent sides. So this 100 is the same as this 100 because you need 80 to become 180. All right, what else do I know? Okay, so it's not true. Let's try the other one. Triangle ABC is isosceles. ABC, this whole triangle is isosceles. That means that I gotta figure out what this angle is. Well, let's see. This is 100, this is 30, that's 130. So how much is this? 50, because that's 180, right? The whole triangle. And now, my friends, look at this. These base angles are equally measured. And you know what the isosceles triangle theorem is, right? Sides opposite to congruent angles are congruent. So these two sides are congruent, therefore, yes, it is an isosceles triangle. Okay, next question. In the diagram of triangle ADC below, EB is parallel to CD. So EB is parallel to DC. Okay. So what else? AE is 9, ED is 5, AB is 9.2. Okay, and what do they want? They want, what is the length of AC? They want to know this length right here. All right. So this is what happens. When you have a triangle and you have a segment that is parallel to a side of the triangle, then how many triangles do you see here? 1, right? And 2, right? So the two triangles that you see here are similar. Let me separate the triangles so you could see them better. So I have a triangle, I have a small triangle. I have this small triangle, okay? And I have the big triangle. I'm not gonna draw the big triangle. You already see it, right? But the small triangle, the name of the small triangle is EAB. And since similar triangles are in proportion, in other words, you have the big triangle, I'm not gonna label it as I said, they wanna know what the length of AC is. So first of all, let's label the sides. So AE is 9, okay? AB is 9.2. Got it? And now let's label the big triangle. AD is 14. You understand what I'm saying? Because 9 plus 5 is 14. And now AC is nothing more than, well, I don't know what BC is, so I'm just gonna put an X in here. So AC is nothing more than 9.2. Is it times X, like 9.2X, or is it 9.2 plus X? Was it 9 times 5, or was it 9 plus 5, 14? Right, so it's plus. So then the length of this whole side is 9.2 plus X. And now I can set up my proportion. So this is how you set up your proportion. You compare corresponding sides. Let me go from the small triangle to the big triangle so you could see it, okay? So I'm gonna set up my proportion. So how do I do it? I'm gonna say 9, which is this side, and it corresponds to this side, right? So 9 is to 14 as, and then I'm gonna compare the small side, 9.2, and what is the length of this AC? 9.2 plus X. I'm just gonna put it in parentheses, you don't have to. Okay then, my proportion is set up, and now I just need to cross multiply, right? So let's see, let's do it. So 14 times 9.2, correct? 14 times 9.2, that is 128.8. And now this times 9. So what is 9.2 times 9? That is 82.8 plus, okay, that was 9.2 times 9. Now I gotta do X times 9 plus 9X. See that? Now I'm gonna solve for X. So I'm gonna subtract 82.8 from both sides. So, what is 128.8 minus 82.8? That is 46. And now, I just divide by 9 on both sides, right? Correct? So, divide by 9 on both sides and I get 5.1. Am I correct? Or am I not correct? Wait, hold on a second. No, that's correct. All right, I did it. So remember, whenever you have the similar triangles, just separate the two triangles, label them, and then just compare corresponding sides, and you'll find your answer. So correct answer, porungum, porungum, porungum. See, multiple choice, but I still have to show the work. Why? Because this is not a guessing game. All right. Problem number 36. It says the coordinates of vertex of the vertices, sorry, of triangle RST are blah blah blah. Which type of triangle is a triangle RST? Okay, then, so how am I going to actually solve this problem? Well, I am going to have to use, me, because I'm smart, right? I'm gonna use graph paper, okay? But you know what? Let's say you don't have graph paper. So what we're going to do is the following. We're gonna find out what the slopes of these sides are, right? So RST. So I am going to draw RST. For the sake of just doing it. Or you know what? Actually, no. I'm gonna be smart. I'm gonna create my own coordinate plane. Just cause. Now on the regions, you have access to graph paper. So you can just use the graph paper, okay? So let's see now, the coordinates, okay, so R is -2, -3. So -1, -2, and then 1, 2, 3. So it's right here, -2, -3. Fine. Then S is 8, 2, so 8. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 2, so around here, right? Yes? And then the last one, okay, so this is S, this is R. The last one is T. T is 4, 5. 1, 2, 3, 4. So 1, 2, 3, 4, 5, somewhere around here. Okay, I'm just doing an estimate. So what kind of triangle this is? Not bad at all. Not bad at all. My estimate, look at my estimate right there. Ha! Son of a gun! I'm nice, but anyways, this is a multiple choice, so I know it's a right triangle. But you know what? Let's say you didn't know, or you're a lousy drawer, or you have no sense of scaling. So what I'm gonna do is basically I'm gonna find out the slopes from each of the sides. Okay. First, so this is let me see, or is it? So I am going to find out first of all the measure of RT. I mean, not the measure, the slope from R to T. So how do I go from R to T? Well, I could say that I went, let me see, this is 3 down, right? And T is, I'm talking about the rise, right? It's 5 up. So 1, 2, 3, and then plus 5, that's 8. Okay? And now, how many to the right? Well, I am at -2, right? On the axis. And I'm gonna go 4. I'm gonna go all the way to 4. So if you're at -2 and you need to get to 4, that's 6, right? So the slope from the RT basically is 8/6. I don't know if you understood, but you know what? That's how I would do it if I was in a rush. But let us do it normally. So the slope of RT. Okay. So for that I need x1, y1, x2, y2. So R is going to be x1 and y1. T is going to be x2 and y2. So what is the formula for the slope? y2 minus y1. So that will be 5 minus -3. 5 minus -3 over, and now with the x's because it's rise over run. So it'll be 4 minus -2. 4 minus -2. That is 8/6. That translates to 4/3. Okay, so that's the slope of RT. Now I need the slope from T to S, correct? The ST. So the slope from S to T is gonna be, so now let's see, ST, S and T. So now I'm gonna make the S's the X1 and I'm gonna make S the X1 and the Y1, and I'm still gonna keep T as X2 and Y2. By all means, if you wanna switch, it doesn't matter. You're still gonna end up with the same thing. So let's see now. Y2 minus Y1, so it's 5 minus 2 over 4 minus 8. 4 minus 8. So I end up with 5 minus 2 is 3. 4 minus 8 is negative 4. Right away, I already know the answer. Look, remember in the previous previous problem when I explained the difference between parallel lines and perpendicular lines? Well, the slope is what determines whether they parallel or not. If they parallel, that means that they have the same slope. Now, if they're perpendicular, okay, then the slopes will be flipped and the sign will be changed. And look at this, 4 over 3 and negative 3 over 4, or 3 over negative 4. In other words, once a number is negative when a fraction, the whole fraction becomes negative. So 4 over 3, 3 over 4, these slopes are perpendicular. And of course, I could have just seen it from the way I graphed it. So therefore, this is a right triangle. Boom. Damn, I'm nice. Okay? Let's move on to the next problem. So, it says, triangle ABC has vertices with x, 3, b is negative 3, negative 1, and c is negative 1, negative 4. Determine the value of x that would make triangle ABC a right triangle. Okay. Justify why triangle ABC is a right triangle. The use of the set of axes, well, it says below, but I put it over here next to it, is optional. Well, you know what? I don't care if it's optional. I'm going to use it. I'm going to use it just because. All right, so you saw it. If you want to pause it to see the point, if you don't have the handout, that's fine. Then if you have the handout, there's no need for you to pause it. I'm just going to say the points. All right, so A is x, 3. I don't know where to put it, so I'm going to skip to B. B is negative 3, negative 1. Okay, so negative 3, so 1, 2, 3, and then negative 1. So right here, this is what we're going to call B. Okay, that's B. C is negative 1, negative 4. C is negative 1, 1, 2, 3, 4. Negative 1, 4, that is C right here. Okay, you see it? Good. So look, this is what I know. This is segment BC. So what would make us, what would be the coordinates of A, okay, or the values of X that would make this this a right triangle? Well, a right triangle has a 90-degree angle. And because it has a 90-degree angle, that means that two lines have to be perpendicular to each other, just like we saw over here. Right angle, that means that they're perpendicular. Therefore, if I can figure out the slope, okay, the slope of this segment, I could use that to create the perpendicular slope. So let's see. The slope of BC is negative 1, 2, 3, 1, 2. It's negative 3 over 2. That is the slope. So if I was to create a right angle, all I have to do, okay, slope of a line perpendicular to BC. Perpendicular to BC would be, well, if this is negative 3 over 2, then this one will be positive 2 over 3. Okay, the whole thing is negative, so this becomes positive. So now, all I have to do is move in that direction until I get, remember what the coordinates of A are, x, 3. So it has to be, so the coordinates of x will be x, 1, 2, 3. Somewhere somewhere in here lies that point. Let me make it red. Somewhere in here lies a point that makes this a right angle. So I'm gonna start here. I'm gonna start from B. So I know what I gotta do. This is the slope that I gotta follow. 2 over 3. That's the perpendicular slope. So let's see. 2 up and 1, 2, 3. Okay. 2 up and 1, 2, 3. I found my first coordinate. You see, it has to lie somewhere in here where the y is 3. So right here, that makes it a right triangle. Okay? So we know what the coordinates of x are. X can be Jesus Christ. 1, 2, 3, 1, 2, 3. X has to be 3, 3. So the coordinates of x is 3. And therefore, the value of x is 3. Therefore, A is 3, 3. Okay, but you know what? There is another value, okay, in here that makes this a right angle. So what would it be? Well, let's see. 1, 2, I'm following this. 1, 2, 3. 1, 2, 1, 2, 3. Okay. Sorry. Let's see. 1, 2, 1, 2, 3. Okay. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay. 1, 2, 1, 2. Oh my God. Somewhere, I don't know, if I trace this line right here, if I was to trace it like that, it hits this line at this point. What could this point be? Well, I would say, just by guessing, I would say 1, 2, 3, 4, 5, 6, 7, 8, 9.5. 9.5, 3. So another value of x could be 9.5. So another coordinates would be 9.5, 3. All right. Now, guess what? If I really wanted to do it algebraically, I don't have a problem with that. It's crazy, but I can do it algebraically. And I'm sorry I'm spending so much time on this one. But first, let us finish the triangles. So this is one of the right triangles, and this one is also the other right triangle. Okay, right here. Anyways, so let's do it algebraically. All right, how do I do it algebraically? I need to figure out the slope that I need. I need a perpendicular slope of 2 over 3, right? So I need a line. This is what I need. I need a line that is perpendicular to BC at C. So I need the coordinates of C, because this was too easy. This was very easy. But I need a line that is perpendicular to point C. And where is point C? Well, let's see. Point C is at -1, -4. That's what it says on the problem. Okay? Okay, so I need oh gosh. Let me see. So I need to summon y equals mx plus b. Okay, y equals mx plus b. That's not a problem. I thought I needed the equation right here of this line, but I really don't need it. Sorry, right here of this line. I could have figured it out, like find the slope and then see where is the y-intercept, but I don't need it because I got what I need. I got a perpendicular slope and I got the point. So I summon upon y equals mx plus b. Now let's replace. Y is -4. M is the slope that I need, which is the perpendicular slope 2 over 3. X is right here, the x coordinate of point C. Plus b. Oh, okay. So now what do I have? I gotta do the math. So -4 equals to -2 over 3 plus b. Correct? Yes, no. Okay then. Now I'm gonna add 2 over 3. Something is not right. I need a line that is perpendicular. Oh my God. Am I doing it right? Okay, let me analyze this. Well, it doesn't matter. So anyways, so I'm gonna add 2 over 3 to both sides. So I'm gonna have -4, okay, plus 2 over 3 plus b. Okay, so far so good. I mean, if it works out, it works out. If not, then whoa. Now, what is -4 plus 2 over 3? Okay, so first of all, I'm going to have to, hey, wait, equals. Right? Okay. So let's see now. I have, okay, -4, that's the same thing as -12 over 3, right? Plus 2 over 3. Because I need the same denominator to do it. Now b becomes, okay, b becomes -12 plus 2 is -10. So this is -10 over 3. So my equation would be y equals the perpendicular slope 2 over 3x minus 10 over 3. Aha. And we know what our x coordinate is. No, we don't. We know what our y coordinate is. Okay? Somewhere, this is the equation I have. So that means that I gotta input a value that I know here. In other words, look at the graph. I have the y coordinate. I know that y is gonna be 3. And I need the x value. I need that x value. I need a value that when I input 3 for the y's, is gonna yield the x. And this is the machine to do it. So let's see. Y is 3, correct? I don't know what x is. Okay. Now I am going to add 10 over 3 to both sides, correct? So, or not, actually not. Look, why am I killing myself? Okay, I'm gonna solve it following the golden rules. Do I have distributive property? No. Do I have fractions? Yes. If I have fractions, multiply everything by the common denominator. In this case, the common denominator is 3. So then 3 times 3 is 9, okay? 3 times 2 is 6, divided by 3 is 2x. 3 times 10 is 30, divided by 3 is 10, okay? Like that. Now I am going to add 10 to both sides, so I'm going to get 19 equals to 2x. And finally, I'm going to divide by 2, and x is 9.5. Beautiful. So that means that when y is 3, x is 9.5. Jesus Christ. It was easier to just draw it and do it with the ruler than just do it algebraically. But that's how you do it algebraically. If you want another walkthrough, let's do it. You found out the slope from here to here, -3 over 2. Then you want to know what makes this a right triangle. You know that right triangle has 90 degrees, so you need this line to be perpendicular to this. We already figured this out. That was easy. This one, perpendicular. So that means that you need a perpendicular slope. Well, from here, -3 over 2, you got 2 over 3. Then you need that line to be perpendicular to this point right here, to this line at this point. So that point was -1, -4. We sum it up on y equals mx plus b. We found the y-intercept to be -10 over 3. We wrote our equation, okay, and then what we did is we input. We knew what the y was, okay. We just didn't know what the x was. So we substituted this 3 right here. Everything is 3 here on the y. See that? 1, 2, 3. We substituted that, and we ended up with x equal 9.5. Okay? Cool then. All right, let's see what we have now. All right, so I'm gonna take a little break, and I'm gonna pick up right here.